Hello everyone. In this video, I am going to explain another circuit synthesis problem. This impedance function is for a LC network, and we have to construct the circuit diagram using Foster form. In Foster form, we are using partial fraction expansion to obtain the circuit diagram or the construct the circuit diagram. First, we have to simplify this impedance function. In impedance function, the numerator have s to the power 2 into s to the power 2 plus 2 into s to the power 2 plus 4, and denominator have s times s to the power 2 plus 1 times s to the power 2 plus 3. Then we can simplify the impedance function. We said LC s. One s will cancel in the numerator. Then we can write s squared plus 2 squared plus 4 over squared plus 1 squared plus 3. This is the final impedance function of the given network. From this one, we can find the zeros and poles. If we consider zeros, we can obtain the zeros from the numerator. Roots of the numerator, s equals 0 and s equal plus or minus root 2 j, and s equal plus or minus 2j. These are the zeros, and if we consider poles, we can obtain poles from the denominator. S equal plus or minus j, and s equal plus or minus root 3j. This one from this, and plus or minus j from this one. And if we plot the poles and zeros in the complex S plane, real axis and imaginary axis, if we consider zeros, there are 5 zeros at 0 or the origin, and plus or minus root 2j. Plus or minus root 2 plus root 2. It is around 1 point value. And next value is plus or minus 2j plus 2 minus 2. And then we can plot the poles. S equal plus or minus j plus 1 minus 1. And the other value is plus or minus root 3j. It is somewhere here, root 3 plus and minus root 3. And you can check the properties of RLC networks and special properties for LC network using this poles and zeros pattern. In the first form, we have to obtain the partial fraction expansion of this impedance function. I will write the impedance function again. ZLC S is equal to S times S squared plus 2 squared plus 4 over squared plus 1 squared plus 3. Then we can expand the numerator s into s to the power 4 plus 6 s squared plus 8 over s squared plus 1 squared plus 3. And then we can again multiply s by this term, s to the power 5 plus 6 s to the power 3 plus 8s over s squared plus 1, s squared plus 3. Then for the partial fraction expansion, we can write s to the power 5 plus 6 s to the power 3 plus 8 s over s squared plus 1 squared plus 3. In this function, the maximum power of the numerator is 5 and the maximum power of the denominator is 4. Then we have to write as plus bs plus c over s squared plus 1 plus ds plus e over s squared plus 3. This is the partial fraction expansion of this impedance function. Then we can write this to the power 5 plus 6 s to the power 3 plus 8 s is equal to as times s squared plus 1 s squared plus 3 plus bs plus c times s squared plus 3 plus ds plus e times s squared plus 1. For this one, we can write s to the power 4 plus 4s squared plus 3. And we have to, now we have to find the value of a, b, c, d, and e. For that one, I am considering the power of s. First, I consider s to the power 5 values. From the left hand side, value is 1. From the right hand side, as times s to the power 4 is s to the power 5 value. Then it is equal to a, and there are no any other s to the power 5 values. Then value of a is equal to 1. Then I consider s to the power 4. If we consider this left hand side, there are no any term for s to the power 4, and right hand side also there are no any power values for s to the power 4. Then I consider s to the power 3. From the left hand side, this is the value 6 is equal to, from the right hand side, s times 4 s squared, then 4 times a, bs times s to the power 2 plus b plus ds times s squared d. Now we know the value of a is equal to 1, then 6 4 into 1 plus b plus d. 6 minus 4 is equal to 2 b plus d. I name it as equation 1. Then I consider s to the power 2. From the left hand side, there are no any terms. From the right hand side, we can get, from this one, there are no any s to the power 2. C into s squared, c, then e into s squared, e. C plus e is I named as equation 2. Then I consider s to the power 1 values. From the left hand side, value is 8. From the right hand side, as into 3, 3a, then bs into 3, 3b, ds into 1, 1d. We know the value of a, 8 is equal to 3 times 1 plus 3b plus d. 8 minus 3 is equal to 5, 3b plus d. I name it as the equation. Then I can consider s to the power 0 values. From the left hand side, there are no any constant value. In 0 is equal to, from this term, there are no any constant terms. And from this one, 3 into C, 3C, and E into 1 plus E. It is my fourth equation. And from second equation and fourth equation, 0 is equal to C plus E and 0 is equal to 3C plus C. From these two equations, we can write C is equal to 0 and E is equal to 0. And then we have to find the value for B and D. From equation 1, it is equal to 2 is equal to B plus D. From this one, we can derive equation for D. D is equal to 2 minus B. And now we can assign this D value to this equation. From third equation, phi is equal to 3B plus D. We can assign D to this equation. Phi is equal to 3B plus 2 minus B. 3B minus B is equal to 2B. And 5 minus 2 is 3. B is equal to 3 over 2. And we can assign this value to this equation. D is equal to 2 minus B. 2 minus 3 over 2 is equal to 4 minus 3. 1 over 2. Value of D is equal to 1 over 2. Value of B is 3 over 2. And value of A is 1. Value of C is 0 and value of E is 0. Then we can write the partial fraction expansion. ZLCS is equal to value of A is 1, S plus value of B is equal to 3 over 2, 3 over 2, S over S square plus 1 plus value of C is 0 and value of D is 1 over 2 times S over S square plus 3. Value of E is 0. And we can write S plus 3S over 2 S square plus 1 plus S over 2 times S square plus 3. ZLC. Now we have to decide what are the elements represented by each and every small impedance terms. For this one, we can write Z1, this one is Z2, and this one is Z3. ZLC is the total impedance, and these are the small impedance part. If I consider Z1, it is equal to S. This is a LC network. Then I am considering the impedance and admittance value of a capacitor and an inductor. ZL is equal to SL and YL is equal to 1 over SL. ZC is equal to 1 over SC and YC is equal to SC. Z1 is equal to S. Then if I check these two elements, Z1 is represent a inductor. This will be an inductor. L1 value is equal to 1. L1 is equal to 1 Henry. And now we have to consider the Z2. It is equal to 3S over 2S square plus 2. Now we can't easily find what are the component denoted by these terms, then I consider the 1 over Z2 value. That means admittance value Y2. If I consider Y2, it is a 1 over 3s over 2s square plus 2. Then we can write 2s square plus 2 over 3s. 2s squared over 3s plus 2 over 3s. S term, one S term will cancel. Then 2 over 3s plus 2 over 3s. Then we have to consider the admittance value. If I consider this value, 2 over 3s, we can get it is a similar to admittance value of a capacitor. Then this will be a capacitor. This one is the capacitor value. I name it as C1. Value is 2 over 3 farad. And if I check this one, I will rearrange it 1 over 3 over 2 times S. If we check the admittance value of the capacitor and inductor, it is similar to admittance value of a inductor. Then it will be a inductor. This one is the inductor value. L2 is equal to 3 over 2 Henry. And these two are connected in parallel because of this plus mark. Admittance value plus mark, that means they are connected in parallel. This component is L2 3 over 2 Henry, and this element is C1 2 over 3 farad. And then we have to consider the Z3. Similar to previous Z2, we can't easily find the what are the elements represented by Z3. Then we have to consider the 1 over Z3. Here 2 times square plus 6 is the expansion. Then we have to consider 1 over Z3. It is equal to Y3. 1 over this one, that means 2s squared plus 6 over s. 2s squared over s plus 6 over s. 1s will cancel, then we can write 2s plus 6 over s. These are the small admittance value. If we check the admittance value of the inductor and capacitor, this one is similar to a representation of a capacitor. Then C2 will be 2 farad capacitor. And if we check this one, I will rearrange it 1 over 6 times S. Then it is a representation of a inductor admittance value. This is the inductor value. L3 is equal to 1 over 6 Henry. For this one, plus mark is here. Then these two elements are connected in parallel. L3 is equal to 1 over 6 Henry and C2 is equal to 2 farad. Now all the three small impedance values are completed. Now we have to connected all the three impedance value. Here all are plus, then all three impedance values are connected in series. Then we can draw the final circuit diagram. The first element is an inductor. L1 is 1 Henry inductor, and the second elements are L2 and C1. L2 is equal to 3 over 2 Henry inductor, and C1 is equal to 2 over 3 farad capacitor, and Z3, this is the representation. L3 is equal to 1 over 6 Henry inductor, and C2 is 2 farad capacitor. Now this is the final circuit diagram of the given impedance function. We can obtain the ZLC from these 2 points.